Hello and welcome back. Today I'm looking at this Crumar Performer. When you engage the brass sounds, it sounds nice and clean, but when you engage the strings, it has this audible hiss sound in the background. I want to know what's to be done about it. Let me show you what it's doing so you'll know what I'm talking about. So you see what I'm talking about? At first I thought it might be the EQ section, but that's definitely not it. First, I want to know if the noise is originating before, during, or after the analog delay line stage. I will need to find the board that is in question, so I look in the schematics and it is P559. So I will unplug the synth first and turn it off. And when I remove two screws, I can flip up the lid and I can look inside for the board that I need to find. So that's not it. It's this one over here. And as you can see, this is the P559 board. I will need to remove the slider caps first and then 6 screws from the front, from the top. Being very careful not to scratch the face of the synthesizer. And then the board will drop down and I can work on everything that's in here. If I had to guess, I would say the noise is originating from the delay lines. I can test this theory by bypassing the delay lines and routing the C output directly to the E input. So I look on the schematics and I find the connectors that have these connection points, and I'm going to pull the wire out of those areas and introduce a jumper that will connect them directly. First, I will want to loosen the connectors up a bit from the pins, or pull them off if I have to. I'm going to slip the wires out of the pins using a sharp tool that I can just lightly press down when I find the right one, and then push out at the same time. Now these are loose, and I will introduce this jumper. I already have a Molex connector jumper that I pulled out of another connector, so I can just slip those into the pin slots and connect those connectors back onto the pins. Then this will bypass the delay lines altogether, and I'll see if the noise is still present or not. I will want to make sure to cover the loose pins, the loose Molex connectors, with some electrical tape, just loosely, it's just for now, to test my theory and see. Now that I know what's going on, I can put everything back the way it was before. The signal at the BBD stage carries with it an inherent amount of noise. It's a noise floor. So if you amplify the signal at this stage or after, you're also amplifying the noise floor with it. So louder noise is no bueno. What's to be done about it? Well, I can instead boost the signal at the EQ stage prior to going into the BBD circuit. Well, if I do that, I need to make sure there's enough headroom in the BBD stage and not to go over the distortion limit, causing a distortion signal. I focused on IC2 and in particular resistor 12. Resistor 12, increasing that resistor should increase the gain of the signal at that point in the circuit. I went ahead and removed resistor 12 and replaced it with a couple of wires. That way I could introduce a resistor substitution box and try different resistance values to see what would give me the best boost. I will show you what it sounds like first before making any changes. And this is what it will sound like with a 33K for R12. That sounds pretty good, but I can tell that it lost some of the bass on the tones. I want to focus on IC5 and resistor 18. I can try different resistance values there to bring back some of the bass in my tone. So I soldered in R12 33K and I moved my wires over to where R18 is. So that way I can try different resistance values. Let's see what it sounds like first. Now I will try different resistance values of 10K and 22K. I think that the resistance needs to be somewhere between 10K and 22K for best results, so I'm going to go ahead and solder in a 15K resistor. Now I want to look into doing the sound Doctrine mod on the sustain. When you press the brass button, the sustain gets killed on the strings. What the sound Doctrine mod will do is allow the sustain to remain on the strings, but you will lose crescendo. So let's just go ahead and see what the sound Doctrine mod is involved here. This is the little board where everything happens on the switch. I went ahead and removed the wire that goes here. On mine it's purple, and this wire, which will be white. I don't like cutting traces on PCB if I can avoid it, so then I soldered a wire connecting the top terminal and the bottom terminal of this particular contact. I did it for both sides. So this is the sound Doctrine mod, and this does it without cutting any of the traces. Now that everything's done, let's see what it sounds like.